Hi everybody, this is Kit again, and I have to say, well, today is the 10th of November of 2013. What is this day? Well, tomorrow is the exam for IB Math, okay, November time zone. So if you are doing November time zone in 2014, next year roughly this time would be your turn. Well, if you are a 2013 student, this video is not for you. Go to bed, go take some rest, just wish you luck and be relaxed and do your best. Okay? But if you're doing it in 2 years or in 1 year, you can take a look at this. Well, I don't want to stress everybody. Tomorrow is the exam day, right? So choose a relatively easy question. This is from 2012. Okay, this is time zone 2 paper. Okay, paper 1. Okay. It happens that this is section B already. The full mark of this question is 16, is number 10. Okay, section B. Okay, it's not too hard. It's quite an easy question, quite straightforward in a way. So fx, they give you a function, it's a fraction, blah blah blah. They give you the graph even, okay, blah blah blah. Okay, it would tell you that the graph has a local minimum at a equals to 1 1. Okay, so that's this point. Okay, and the maximum at B, you kind of don't know where is B, but okay, it's probably roughly here. Okay, now due to the fact that if it's really there, okay, due to the fact that there is a local maximum, you kind of know there is no asymptote, at least in this direction, at least not here. Okay, because if in an asymptote, okay, if you have an asymptote and the thing would approach the asymptote in an upward direction, the thing would just get higher and higher but never touch the asymptote, which kind of say there is no maximum point. There is no local maximum. So just by this, there is not. This is not an asymptote at that area. Okay, it may be one far away, maybe one on this side, but at least it's not here. But never mind. The question is not about that. The question is simply find the first derivative. Okay, it's so straightforward that it has to give you the answer. Okay, so you can check your answer at the end. It also tells you that you're gonna use quotient rule. Oh, come on. Can it be easier? So if you forgot the quotient rule, check the formula booklet. I don't care. Okay, so just look at the original function fx. Right, okay, sorry for the turn. Okay, let me adjust the camera. Fx equals to x over negative 2x squared plus 5 minus 2. You got to remember quotient rule. If not, go to the formula booklet. You have to understand what it's talking about. But this is my way of remembering it. Do it your way. It will be the same anyway. First, you take the denominator, square it. Square the whole thing. While you square this, you also copy it once on top. Times differentiate the numerator. Okay, differentiate x, you get 1. Minus, copy the numerator, copy, times differentiate the denominator. So negative 2x squared, x drop down is negative 4. 2 minus 1 is 1, x plus 5. Okay, differentiate this 0. That's it. Okay, remember this way because if you mix up which one you differentiate first, due to the minus side, the answer would be different. Okay, so take it away. How do you remember which one to differentiate first? You should differentiate the numerator first. Okay, do a little bit of expanding. Okay, negative, positive, right? 4x squared, negative, positive, negative 5x. Remember, whenever we do quotient rule, the denominator is never expanded. This square is never expanded. It's useless. Okay, it won't help. Okay, what do we got here? Okay, so 4x squared minus 2x squared. Okay, it's 2x squared. 5x minus 5x gone, minus 2. Does it look like what they want? Oh, it's exactly what they want, so we stop here. Okay, done. Second part, find the coordinate of B. Okay, what is B? B is the local maximum. That just tells you to find the maximum. How do you find the maximum? Set the first derivative be 0. So set it be 0. 0, what does it mean? It means this equals 0, so 2x squared minus 2 divided by blah blah blah. equal to 0. Okay, what you do is you multiply the bottom to the other side. Always do that. But anything times 0 is just 0. So 2x squared minus 2 is 0. Put the 2 to the other side. 2x squared equal to 2. Divide the 2. 2 over 2 is 1. X squared is 1. X is 1. Is that it? No. Plus or minus. Okay, whenever you do square root, it's plus or minus. X is plus or minus 1. Now note that they give you A. A is a local minimum. While A have x equal to 1. So that's kind of telling you that the positive 1 is for the minimum. So that's so obvious that x equal to negative 1 should be a maximum. Sorry, because there's only one minimum, only one maximum. Now, it will happen that for this year of the syllabus, inside the marking scheme, you have no need to prove that this is actually a maximum. No need to do the side graph, or no need to plot it to the second derivative to prove that this is really a maximum. But to play safe, I would really encourage students to try to do this. Okay, now pick your method. Okay, the following two methods, just pick one of it. You either do the second derivative test, or you do the first derivative test, derivative side test, right? We'll do a side test. Okay. Now, due to the fact that the first derivative is already a fraction, and if I want to get the second d, I need to differentiate this again. It's not easy to differentiate fractions, so I probably won't choose the second d. But if you are one that wants to do it, first you differentiate it. So you find the second d. What you're going to do is you plug your value of x inside the second derivative. So you would look for the value of f double prime negative 1. If the value happens to be a positive number like plus 5, okay, positive, that would mean you have a minimum. While if you have a negative number, that would mean you have a maximum. Okay, that's the second derivative test. This time we do the first d test. Okay, simply because it's hard to differentiate a fraction. So usually I draw this table. You may have your way. It's up to you. Doesn't really matter. Okay, x. We plug that into the first d. So when you plug negative 1, obviously it's 0. For some number smaller than negative 1, let's say maybe negative 2. Okay, where is our first d? Okay, this is our first d. Now when you plug numbers in, you gotta have some technique. Tell you what, look at the denominator. It's something squared. What's so special about squared? No matter what you squared, your final answer is positive, unless it's 0, which is not possible for denominator to be 0. So unless it's 0, it must be positive. So the bottom must be positive. Okay. For x, what do we plug again? Negative 2, right? Negative 2, a number smaller than negative 1. So negative 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. 6 is positive. Positive over positive is positive. So in the side diagram, this is positive. Sorry, can you see it? This is positive. Okay. For x bigger than negative 1, okay. 0 maybe? 0 is a good choice, right? Again, for the denominator, is something squared, no matter what it is positive. 0 squared is 0. 0 times 2 is 0. 0 minus 2 is minus 2. Negative, positive, negative. That means after it is negative. A positive gradient means increasing, then go a little bit flat, then decrease. Obviously, this is a maximum, as we want, because we want b to be maximum. It would happen that this part doesn't bear any points inside the marking scheme, but just to play safe. You would want to get full mark, right? Now the competition is really high. To get a 7, you need 90% for paper 1, at least 90% for paper 1. So you may want to stretch, okay? Get every mark you can. So we have got the x equal to negative 1. Just got that. Well, just the x coordinates means both x and y. So we would plug this back to the original equation to find y. So let's do that. So f minus 1 equals to, okay, the top minus 1 divided by negative 1 squared is 1. Negative 2 times 1 is negative 2. 5 times negative 1 is negative 5 minus 2. Minus 2 minus 5 minus 7. Sorry, can you see? Minus 2 minus 5 minus 7 minus 7 minus 2 minus 9 minus 9 minus 1. Negative, negative, positive, 1 over 9. Therefore, the coordinate is just negative 1, 1 over 9. Okay? Negative 1 is here. That means this point have y okay, 1 over 9. So this is the maximum, okay. So that means this line would drop a little bit first, okay. This means this is not an asymptote, okay. Well, as I said before, never mind, it's not what we want. Given that C part of the line, y equal to k. K is a number, right? So remember that, okay, y equals to number line. Look, how does it look like? It's a horizontal line. It's just that, okay. Does not meet the graph of f. Find possible values of k. What does it mean? Now, if k is 2, okay, let's say k is 2, then you would have a vertical line like this. Okay, sorry. Does it cut with the graph? Of course, yeah, you have 2 points here. So how would that horizontal line not meet the graph? The only possible scenario is that it's between this gap. Between this gap. We know that the maximum points have y value 1. The minimum points have y value 1 over 9, 1 over 9. So obviously, if k is inside this interval, your horizontal line would not meet your graph. It's just that. Nothing difficult. So k has to be smaller than 1, bigger than 1 over 9. Done. That gives you 3 marks. No step needed. Just write this down. Everything would follow. Okay? This is it. Not too hard. Okay? Because, well, just before the exam day, tomorrow, again, November, paper 1 time. Good luck. And, well, see you later.